Okay, so we're going to be doing logarithms, solving logarithms today. Okay, so we did some basic ones yesterday. Today we'll move into a little more advanced. Okay, so let's look at our first one. So when we say solving, what are we doing? Well, when we're finding solutions or zeros or roots, basically solving for x means we're isolating x, trying to get x by itself. Okay, so in this first one, I've got 5 plus e to the x plus 1 equals 20. So first thing I do is get this x by itself. So I'm going to subtract 5 on both sides. Okay, and I'm going to get e to the x plus 1 equals 15. Okay, now there's going to be numerous ways of doing it. Now, the easiest or the most common sense way is, since we're dealing with the exponential, we can use log. So I'm going to take the natural log of both sides, because we learned in Algebra 1 that basically we can do anything we want to an equation as long as we do it to both sides, the exact same thing to both sides. So I'm taking the natural log of both sides. Now, there's a couple of different ways we can do this. One is we can use, since we're dealing with a log, use the power property. The easiest way to get x out of an exponent is use a logarithm and using the power property. So we're going to take this power right here, we're going to move it out front. So we get, let's see, x plus 1 times the natural log of e equals the natural log of 15. Now, the natural log of e, that is 1. That is one of my identities. One of my identities says the natural log of e equals 1. Okay, that is a natural log identity. So here we go. So that basically means if that's 1, we get x plus 1 equals the natural log of 15. Subtract 1 from both sides. We get x equals negative 1 plus the natural log of 15. And that's our answer. And we've plugged that in the calculator and we'll get a value. Okay, so that is one way of doing logarithms. Now, the other way of doing it is using a different property. So here, when I have this, there is a property that says that ln of e to the x equals x. That is the inverse identity. Since the natural log and e to the x are inverses, I'm left with x. So for this one, we could have used it here, and that means that basically I would have ended up with just this as x plus 1 equals the natural log of 15, which means I end up right here and I get the same answer. Okay, so there's a second way. Also, right here, before I took the natural log of both sides, I also could have used this property that says a log base a to the x equals y, and you can change it to its exponential form, a to the y equals x. Okay, which means that we can also change it from logarithm to exponential or exponential log. So I could have used this. This is my a, this is my y, and this is my x, and changed it back to its log form, and I would have gotten log base e of 15 equals x plus 1. And remember, log base e is the natural log, and basically you would have been left with the natural log of 15 equals x plus 1. Okay, and then of course that leads us back to here. So 3 different ways of thinking about this problem, all leading us back to the exact same answer. And that's one of the best things about mathematics, is that you don't have to do it just one way. There's going to be a bunch of different ways. So however you see it, that's the way you should do it. Okay, but that means that if you see an exponential and you're solving for x, you're either going to, 1, take a log of both sides to move x from its exponent, or you're going to change it to its log form and solve. 9 times out of 10, though, it's easier just to use a logarithm to move it. Okay? All right. So our next problem we've got a logarithm this time. Okay, so the easiest thing to do is changing it from its log to its exponential form. But before we can do that, we have to deal with this too. So we use the power property to move it. Okay, so we get log base 8 of x squared equals 3. Okay, so 9 times out of 10, if we got a logarithm, we got to condense everything first before we can move on to solving. So next, I'm going to use the property here that we just talked about, changing it from its log to its exponential, and that's 8 to the third power equals x squared. So 8 cubed equals x squared. And now, real easy, you take the square root of both sides, and you get x equals plus or minus the square root of 8 cubed. Okay? Now, since we did take the square root of a square, we do get this plus or minus, but we know for a fact we cannot use the negative one because you're not allowed to plug a negative into a logarithm. Okay? When you plug in a negative number into a logarithm, it's undefined. The domain of logs are from 0 to infinity. Plus, think about it. What power can you take a number, because this is a base, to this power? What power can you take a number to get a negative number? Well, you can't. There's no power. There's powers that will turn something positive, but there's no powers that will turn something negative. So you can never have a negative inside a logarithm. Okay? Now, you could have done this a different way if you wanted to. If you really know your exponent rules, you could have, instead of moving and done the power property, you could have actually moved it. You could have divided both sides by 2. And that would have given you the log base 8 of x equals 3 halves, and then changed it to its exponent form, which would have given you 8 to the 3 halves powers equals x. And 8 to the 3 halves power is the same thing as that, the square root of 8 cubed. So it just depends on how you want to do things. And again, that's part of the brilliance of math, is that you can do things more than one way. Okay, so again, let's look at this one. It's an exponential, so I'm going to look at it 2 ways. One way, again, to think about it, to move an exponent, you can use a logarithm. So I'm going to take the log base 4 of both sides. Well, why would I do that? Because now I have the inverse property, the log base 4 of 4 to the x minus 3. That leaves me with x minus 3 equals log base 4 of 9. Add 3 to both sides. That means x equals 3 plus log base 4 of 9. That's my answer. Now, you could have done it that way, or you could have changed the exponent to its log form. So again, this is my base, so log base 4, and it's going to be 9 equals x plus 3. Because remember, this power, this to this power equals that. So that's what I did, is I basically changed it back to its log form. And in doing so, basically I end up in the same position I do right here. This time, oh, this is supposed to be minus. It's supposed to be minus 3. So then we add 3 to both sides, and we still end up right there. Okay, so either way, however you see it, taking the log of both sides or changing it back to its log form. Multiple ways of doing it. All right, the next one. So I see these two logs together. Now, when I see that, just like the one previous, I'm going to condense first. I don't want a bunch of logs flying around. I want to see if I can break this into one, or condense it into one log. So the log property, the quotient property, says if you have two logs with the same base and there's subtraction going on, I can condense it by dividing. Okay. Now I have one log equaling a number, which means that I can use the exponential form. I can change this, so it's going to be 3 to the first power equals that. So that gives me 3 to the first power equals 2x over x minus 3. And now I'm back into an algebra 1 position where I'm just basically solving for x. Couple of different ways of doing this. Easiest is multiplying by x minus 3 on both sides. So you get 3x minus 3 equals 2x. And you get 3x minus 9 equals 2x. And then subtract 3x from both sides. And you get negative 9 equals negative x, which means x equals 9. And we can double check it. If we plug it back in here, this would be log base 3, and then 2 times 9 is 18, and 9 minus 3 is 6. And 18 divided by 6 is 3, and that's that identity, 3, 3, 1. That's this identity. The log of a to the a equals 1. So when you see logs on one side and a number on the other, you want to condense and change it to its exponential form. That's usually the easiest way to do it. Okay, there are a couple other ways, but that one I don't want to do it a different way. Now, the last one, again, very similar. First, I'm going to do any kind of condensing I can do. Okay, so I'm going to use the power property to do that. So I get the log of 4 squared. And on this side, I have the same logs with subtraction. So again, I'm going to use the quotient property and get x over 6. Now, since I have 2 logs, one on either side, and they're the same base, I can use the one-to-one property. The one-to-one property says since this and this are equal, that means that this has to also be equal to that. So x over 6 has to be equal to 4 squared. And then we multiply both sides by 6. And then we get x equals 16 times 6, which is 96. So our solution is 96. X equals 96. Okay. Now, you could have, if you really wanted to, you could have subtracted this log base 4 squared on both sides and gotten all the logs on one side and gotten log of x over 6 minus the log 4 squared equals 0. And then condensed this and gotten the log of x over 6 times 4 squared equals 0. Okay? But at that point, you would have been back to where you were on the last one, where you have a log on one side and a number on the other. And since this logarithm is base 10, changing it to its exponential form, 10 to the 0 power equals that. So 10 to the 0 equals x over 96, because 6 times 4 squared is 96. And 10 to the 0 power is 1. And you multiply both sides by 96, you still get x equals 96. It's just a couple more steps. It's much easier to use the one-to-one property here on the left side, but you could absolutely do it the other way. Okay, so here's 4 different styles, and you can see you can use multiple ways of solving each one. That's math.